Welcome everyone. Office hours time again. Favorite time of the month for me. Hopefully favorite time of the month for you, but who knows? But one of my few chances to actually get out and about, but I'll have some exciting news about getting out and about very shortly. Sing out on the chat line if you can't see me or hear me. Hopefully all the various checks have been done. When you see my head do this, it means I'm looking at the chat monitor over there. But other than that, I'll do my best to keep looking straight down the barrel. Hopefully you've all had a good break. We're now back into the new year again. February, January holidays are over. All the stuff is ramping up. Conferences are starting to ramp up. I think, in fact, one of the conferences is underway as we speak, but we'll talk about that in a second. Let me share my screen and we'll get straight into the content. Okay, hopefully now you can still see me and you can see an opening slide. As always, bang out in the chat line if you cannot. For anyone that's new to my office hours, it'll always look a bit weird. The slide content is pushed down to the bottom or to the left. That's because when we turn this into a YouTube video, we'll put me at the top right somewhere. And as we all know, there's nothing worse than someone's webcam interfering with that precious piece of content that you really wanted to see in the slides or in the code demos. So we do it this way, hopefully keep you happy on this call tonight, and also keep you happier if you ever go watch the YouTube videos afterwards. As always, I like to do some bits and pieces. Let's fly through these as quickly as we can. As I said at the start of the year, I'm going to aim to do a database video every day. So far, so good. Database video number 40 goes out tomorrow. The plan is to get to, I think, the mid-60s sometime. I'm taking a couple of weeks off in March to go traveling with my partner. And so, yeah, the plan is get a daily video out till then. So about 30 more to go. I won't say this was a mistake, but good fun. As we speak, the Armored conference is on, and you might be thinking, well, I don't live in Denver. I'm not in Denver at the moment, but they also have a virtual track. So it's not too late. Jump onto your Armag website and you can join. Effectively, it's nighttime for me. So their day is just about to start in the US. So yeah, so you can jump on, watch the virtual event there. I don't know what it costs. Maybe it's free, I'm not sure, but check the website, jump onto that conference as well. Utah training days are coming up on March 7th and 8th, just 4 weeks away. So if you're in that neck of the woods, get along to that event as well. Apex World, 30th and 31st of March in the Netherlands. If you're anywhere in Apex based in the Netherlands, and I think there's a lot of Apex in the Netherlands, you should try to get along to that one. Apex Adria. Apex Adria, excuse my terrible pronunciation, 21st of April. So we rolled into April now. And then April, what do we got here? 24th, 25th, the Oracle user group in Norway. I'm very fortunate enough to going along to it this year. So I got a paper accepted and went cap in hand to get some travel funding, and I was very fortunate to do so. So cannot wait to go back. I think the last time I might have been there was 2014. Way back when we used to do the cruise, but yeah, absolutely thrilled to be going back to Norway, catch up with friends there. So it's been a long time, a lot of virtual conferences, but yeah, be thrilled to go back to there. And also on the same trip, this is how I managed to justify it. On the same trip after Norway, I'll be looping down through Berlin for Apex Connect. Very strong Apex content-based conference there, but also if you're more of a generalist, there's some good stuff on database design. I think Chris Saxon will be giving a talk there. And I'll be giving a talk there on some database features that are coming up soon. So if you're in Berlin or if you're in Norway, please jump on, come along, say hi, let me buy you a beer. Now, I've done that fairly quickly, and I always finish with this slide, support your local user groups. I want to take just a moment of your time. Now, a good friend of mine reached out to me after last office hours and said, I wish you'd just jump straight into the tech. You spend a bit long on the conferences coming up and stuff like that. And this is not me calling him out and trying to criticize him, whatever. It's great that people, especially good friends, are happy to provide feedback. I always want to make these sessions more valuable for you. But I just thought I'd justify why I do this, because some people might, be, especially a lot of people who are actively already involved in user groups are probably going, hey, Connor, enough already. Get on with the tech content. But I think the reason I do this, and I will keep doing this, even though probably at the behest of my friend, he said keep it short, is two reasons. One is the last few years, user groups have done it incredibly hard. But even if you put COVID aside, There is that sort of philosophy nowadays, especially in the world of blogging and stuff like that, and even now with AI and ChatGPT, is that we often have this concept, especially in sort of in the IT world, that all our content should come for free, and that we shouldn't have to invest anything besides our time to consume content and become better IT practitioners. And the problem with that is, of course, is user groups who are trying to put on things to improve our community often bear the brunt of that, because people say, I'm not paying $100 to go to a meetup, I'm not paying $200 to go to a conference, etc., because I can get a lot of that stuff for free. I don't think you can put a price on the value of community, and I don't think you can put a price on the value of networking, which is why I continue to push these things, because user groups are facing that tough time because people like stuff for free. It's the reason we use things like Facebook and all this kind of stuff, except we get smashed with ads. So I'd like to keep pushing user groups, because it's like when we all got locked down in COVID, I remember I said in one of my office hours sessions, I said, we didn't know how important being around other people was until it was taken away from us. And I think user groups are the same. We're so easy to take the massive effort the user groups put in for granted that I think we'll be absolutely lost if they suddenly disappear. So I'll keep pushing it. Even though I take my friend's good point, and please rest assured, given that you now know this, if you're already an active user group person, I will take absolutely no offense if you choose to join these office hours at about 5 or 10 minutes past the hour. Absolutely understand, but I will continue to do it, even if I can just reach that one person who's not currently a user group member to reach out to their local user group. Anyway, enough of me pontificating. Let's get on with things. If you don't know my podcast, I just finished publishing an episode with Maria Colgan. Had a great old chat with Maria a couple of weeks ago. So episode 1's just gone out. Episode 2 will go out next week. It's just a matter of finding time to edit them in amongst all these daily videos. But yeah, if you want to hear more of Maria's backstory, but the podcast isn't necessarily all about tech. It's more just about the backstory and how Maria has climbed the ranks through Oracle and what she does on a daily basis. So episode 2 comes out next week. Episode 1's been out now for a week. Okay, a lot of stuff to cover tonight. We've got white papers, buffer cache activity, CDB PDB wait events, maximum in-list elements, evolving to array processing, constraints unlocking, rebooting text indexes, timing and set timing. It's 8 topics. There's a lot to get through, but we'll do our absolute best, because some of these hopefully won't take too long. This one came from a long-time supporter of all the office hours, including my own, Judith Menzel, who's in Israel. And this is her question. In fact, her question came in like this. It's a beautifully formatted phrase question, several paragraphs, etc. But I'll paraphrase it down to effectively what a lot of people say, and I think Judith phrased it far more politely than I will. And that is, will you stop breaking the damn links to the damn content on the damn Oracle website? And this is true. This is a shortfall, a frustration for many in the community. It's a frustration for us here inside of Oracle. The reality is, when you've got a database company that's been running for 40 plus years and 25, 30 of those have been pushing out content, it used to be in hard copy, now it's obviously online, categorizing it, keeping it, checking it for relevance, etc., is a challenge, and I will happily concede we haven't done that particularly successfully. So all I can say on that is we're sorry. It is, I know, frustrating. It's the same for me when you click on a link and you'll bookmark that link, and then what happens is you think, oh yeah, I'll go back to that white paper on something, and that link no longer works. And that's because it's been reshuffled or we've lost the forwarding address, etc. I know it's frustrating. I don't have any massive solutions internally for you. Just all I can assure you is we know about it. It's not like we just go, oh yeah, we don't care. We are trying to effectively clean up a mess that is 30 years in the making. But I thought I'd throw in a few little hints and tips here to hopefully, if you're looking for white papers and stuff, that you can hopefully find them. So these are the kind of things that I do when I'm looking for a particular white paper that's out there and it's no longer the link that I thought it was on. It's like someone's laughing at me about I think it's something laughing at my links. Oh, Judith is here. Well done, Judith. This is your question, Judith. So this is the kind of things I do with Google. I'll look for siteoracle.com and extension PDF. And if I do that, you get anything pretty much on our website that has a PDF extension, as in Acrobat. Now, that sometimes helps you get stuff, but as you can see in the screen dump I've put there, you often get a lot of the user manuals, reference guides, etc., which come as part of the standard documentation. Another option you might want to choose is the same thing, Cite Oracle.com, and type in TWP. There used to be a standard inside Oracle that whenever you were doing a technical white paper, the file name contained TWP, technical white paper in it, and it was often the prefix. So this is a great way of narrowing yourself down to, you'd start with this search and then you might add other keywords to basically get to the particular topic of interest. So TWP is a good way of getting to these things. Similarly, if I can't, there are some white papers that no longer have TWP, but if you put in white paper, the reason that can be useful is every white paper we publish normally has on the front page, it has the subject, the topic, and it says an Oracle white paper. So if you search for the phrase white paper in quotes, then you'll get that. The only problem is, of course, as you can see in the results, generally the preview shows you the page in which that term was found on, which is the cover page. So often not enough content there, but just some little hints and tips here. So as I said, it's frustrating. I know, I wish I could solve it for you with a wave of my hand, but I cannot. These are my go-to search options when I'm using something like Google. So Cite Oracle.com, you can use in title or all in title, which means all the words you type all have to be in the title. So combinations of Cite Oracle.com, title, extension PDF if you're looking for PDF files, in URL, in anchor, etc. So if you can work to those kind of things where you can narrow your search down, the likelihood of you finding the white paper that you used to easily reference is much, much higher. I know that's not a solution, but hopefully it gets you a little bit of progress. I did this probably, what was that, 2021? I did this a year or so ago, a couple of years ago, where I had the same frustration. So what I did was I actually went and found as many TWP links as I could and stuck them on my blog. So there's a good starting point there. If you find others which are not on my blog, please drop me a line on Twitter, DM, and I'll add it to this webpage. So at least then you've got, at least on my blog, a list of all the TWP white papers that I found when I did this search a while ago. I'm happy to keep that up to date. If you send me links, I'll put them on there, and at least then you've got that, hopefully, one central locale. And I'll do my best not to erase my blog by choice or by accident. So that's question one. See, as I said, nice and quick. Hopefully, Judith, that helps you out, and hopefully you get some hints and tips there. Okay, I should notice I've activated the chat for everyone, so you can talk to each other, you can talk to me, whatever. So don't feel you can. I have no problems if you have private conversations on the chat line while we're on our office hours. Buffer cache activity. Here's the question that came in. And it was funny, it was logged in our office hours site, so it wasn't sent to me directly, so I was referred to in third person. In a talk given by Connor, he talks about how reading data from the database, he talks about single row fetches and how expensive it can be. Are there any statistics gathered in the database that would indicate if this process was occurring a lot? And the answer is yes. Let's walk through a little bit of the background. I don't want to repeat that entire talk, but I'll give a little bit of the background, a couple of slides from that talk to help provide the background as to what I was referring to and how we can monitor it and improve things. And ultimately, as I said in the talk, is this was all about the cost of latching when it comes to retrieving data. So your typical program, almost any program, either queries one row or it queries multiple rows. And so if you've written something in Java, it looks something like this. You've got open a result set, and then you loop through result set doing fetches until you've exhausted the result set. It's a very typical and common programming sort of model, and it's a bad one because we're doing single row fetches. And the reason single row fetches generally can be a expensive operation in the Oracle database is we don't store information in rows. Now, that sounds a bit obtuse given that you might be thinking of tables being as rows and columns, but down in the storage layer, Oracle data is stored, as most of us know, in blocks. And so to read data, to exercise a fetch from a query, you actually read blocks from the database, not rows. And so it sort of looks, in a very simple schematic, something like this. I've got a data file on disk, which is broken up into typically 8K blocks. Those blocks will be read into memory because historically, and to some degree today, disks are very, very slow and not great for concurrent access. So we read that information from disk in blocks into memory, and then from memory, we extract the information from the blocks to return our rows to our calling environment. That's Buffer Cache 101 in a nutshell. So the problem is that intermediate memory layer. Yes, we need it for performance, but access to memory from a database perspective is complex. because lots of people access the same memory at the same time, and obviously lots of people change memory at the same time. So it's all got to be protected, and we protect it with latches. And so typically when you fetch a row in a database block that's currently in memory, the logic looks something like this. I need to make sure that the memory I want to access, and perhaps a linked list of memory I need to walk along to find that block, isn't going to get swept out from underneath my feet while I'm walking along it. I don't want people changing the pointers, etc. So to make sure no one's going to touch it, I'll grab a latch which protects that list of blocks. So I'll get the latch, I'll walk along the list of blocks, find the block that I'm interested in, jump in there, extract the row I want because I'm fetching a row. I've now got the row. I no longer need exclusive control over that, so I can release the latch and I can move along. And that's a single row fetch in a very simplified nutshell. Get the latch, find your block, find your row, release the latch. But of course, programs don't just do single row queries. They fetch rows. They loop, fetch, 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 fetch until the cursor is exhausted, which means get the latch, find the block, find the row, release the latch. Get the next row. It's probably in the same block. There's a very good chance if the predicates are sort of aligned that way. So it's get the latch, walk along the list, probably the same list, probably the same block, get the second row, release the latch, get the third row, get the fourth row, get the fifth row. Every time, grab a latch, walk the list, fetch the row, release the latch. And so you're getting a lot of latching, right, just to actually fetch rows. Now, a better strategy is a thing that we have in the database called pinning. And pinning, as the name suggests, is like when you stick a pin in a notice board with something that's a piece of information that's of interest to others. And the way we do that is when we fetch a row, I want to let the database know that I'm not just doing a single row fetch. I'm fetching a row, but I'm probably going to come back and fetch lots more. And so you're sort of letting someone know, by the way, this is not a primary key lookup. This is a fetch that's looping through multiple rows. And so the way that works is you'll get the latch, you walk along the list until you find the block of interest. And then rather than just grabbing the row, I'll put a pin, literally like a drawing board pin with a saying, hey, Connor's here. Please don't mess with this block while I'm here. And then I can release the latch because I've left a sort of a piece of information there to tell others this block is special currently. Now that I've put my pin in, I can find the first row in that block, find the second row, find the third row, find all the rows that are relevant in that block. And then when I've finished with that block, I then grab the latch because I'm about to get exclusive access, take my pin away and release the latch. So what I've done is I've dramatically reduced the amount of latching. It's rather now it's latches per block effectively as opposed to latches for every single row. And the question was, can we monitor this? Can we see it? Can we see what's going on? And we can. Let's do another demo, or first demo for the night. First demo? Yes, let's do a demo. So I'm going to create a table here. It's, what is it? It's 10 copies of DBA objects. So probably around 800,000 rows. Yeah, 800,000 rows. What I'm going to do is I'm going to simply loop through. In fact, I'm running it for the first time here just to make sure all the various latches that will be involved in compiling this piece of PL SQL, executing, etc., are all get put into memory, so that's not going to dilute the result. So I've just run this. I'm just doing a single row fetch through 800,000 rows. This is the example of our poor scenario. Fetch a row, fetch a row, fetch a row, fetch a row, etc., 800,000 times. Now that I've done that to sort of prime the cache and get all this compiled, now let's rerun it, but this time we'll take some measurements of some of the latching structures. So I'll create a table called latch1. It's a copy of v.latch because v.latch is one of the in-memory performance views which has cumulative counters for all the latching activity in the database. So if I want to see a delta, I need to take a copy, run my experiment, and then look at v.latch minus the original version to get the delta. So let's now do that same piece of code that's already now been compiled in the library cache. We simply loop around 800,000 times. It's remarkably quick. And then what we do is we say, let's compare v.latch as it is now, and we'll do a full outer join back to latch1, which is the copy of v.latch we took before that experiment. And you can see that I'm just doing gets minus L1 gets to do a delta from after and before. Now, a lot of stuff goes on, but luckily we can find right down the bottom the probably most relevant latch here, which is cache buffers chains. Because we walked along chains of blocks in the buffer cache And then when we found that to make sure that that walking along that list was protected, we would take latches. In fact, we took 1.6 million of them. Now, 1.6 million might have a bit of familiar bell to it. If I take the number of rows in that table times 2, it's about 1.6 million. This is that concept of effectively go there, find it, grab a latch, find a block, release the latch, etc. We've got various 2 times the number of latches based on the number of rows that we got there. And you can see this is probably how we could look in our database to see if we've got massive numbers for cache buffers change latch. There's a reasonable probability that we're doing a lot of latching due to maybe single row fetching. So let's compare and contrast that with now a better example. So I'll drop my latch one table. I'll recreate it. So now it's the current version of $3 latch to get our current stats. And all I've done now is trivially change the query to just do a for I in select star. If you're not familiar with PL SQL, an implicit cursor loop like that will automatically do what we call array fetch of 100. And the moment you tell the database you're doing array fetching, as in give me 100 rows at a time, it goes, if you're telling me to, I'm going to probably get 100 rows at a time, I'll use the pinning model. I'll pin, grab it to 100 rows, release the pin. So in this case, you can see, it's a lot faster, which is obviously a good thing. Here's my same Delta query. Let's run it. And now, rather than 1.6 million gets of the cache buffers change latch, we only did 52,000. Now, if you're looking for an order of magnitude roughly, if I look at the number of blocks in the table times 2, it's about 35,000. It's not exactly 1 for 1, but it's in the same ballpark. Generally, you're looking at a couple of latches for each block you needed to navigate to, as opposed to each row you needed to navigate to. So you can see that's a dramatic improvement there in the amount of latching going on. So if you look at your AWR reports, etc., and your cache buffers change latch numbers are just typically, if they're all asterisks or all hash signs, then you know that it's absolutely massive. Let's go back to the slides. The key thing here is monitoring that latch activity is going to give you maybe an inclination as to the kind of things that are going on. The other thing you can look at is just at $3 SQL. If you look at, for example, various queries where it says the number of rows processed was, say, 1 million, and the number of fetch calls was 1 million, then you know you've got that 1 for 1. If the fetch calls is dramatically lower than the rows processed, then there's a good chance you're doing array fetching. And the reason I wanted to mention that is it's very easy as DBAs or any kind of IT practitioner to get what I call into, a friend of mine from many years ago, Garja, used to say compulsive tuning disorder. And that is, you see these giant numbers in an AW report, for example, latches, and you go, we have a latching problem, must do. Well, earlier on when I was running these demos today, I took some AWR snapshots before and after. And here is the results of this. Even though I was running several of these all in the same session, you can see that where did I lose my time? Well, I had a little bit of time here on DB sequential time, 1.4% of overall time. The rest is all CPU. I was literally just burning away at memory. So I lost 1.4% of my time doing some IO. If I look further down, with all that latching going on, the cost to me was still 0.01% of the overall response time. Now, there's a couple of reasons for that. One is I would probably need to run dozens of concurrent programs smashing away at those common blocks in order to really get the latching workload up. And the second thing is I was a little bit loose with the truth. Some of our latches now in the Oracle database have more extended structures to allow both exclusive and shared access. So if you're doing a query now, Oracle is now smart enough to go, you'll definitely need to be walking along this list of linked blocks in a read fashion, because you're not doing select for update, you're not doing insert update or delete. Therefore, I'll let others walk along with the same latch. We have the concept of shared latches now, which therefore reduces the amount of contention and allows greater concurrency. So there's a lot of cool stuff in the Oracle database, but the key thing word of warning here is ultimately, no matter what the numbers are in terms of how much latching and stuff you're doing, the question is, what's it doing in terms of impacting your customers? And in this case, it's less than 0.01% impact. The reason I would look at removing single row fetches is not to reduce the latching, not to reduce the CPU consumption, not to reduce the CPU consumption, which admittedly on a cloud system equates to dollars. It's for this. You saw, hopefully, that demo. The moment you do array fetching, the performance benefits are huge. So if you can focus on removing single row fetching, not because of latching, not because of contention, not because of CPU, but simply because you'll have happy users, that's generally going to be the best way to go. Focus on efficiency and response time, and the rest of it takes care of itself. CDB PDB wait events. Here's the question that came in. We look at wait events from VDOL event histogram and VDOL system event to help with tuning. That previous AWR slide you just saw with AWR events on it, that's effectively what this, let me say that again, maybe in English. The previous slide you saw with an AWR report, which showed foreground and background wait events, typically is sourced from these VDOL views. So it's effectively one and the same thing here. Where was it? That's right. We look at wait events, VDOL event histogram, system event tuning. When looking at these in the CDB PDB configuration, which takes precedence, the CD, I can't speak tonight, which takes precedence, the CDB or PDB, or are they linked? And the answer for that is, it's very, very cool. We put a lot of work into the concept of PDBs and CDBs working in harmony with each other, yet still, for all intents and purposes, if you're in a PDB, you appear totally isolated, as if you were a standalone database, even though by definition you're running under the umbrella of a container database. And to help demonstrate that, I thought I'd show you some wait events in both a PDB and a CDB on the same system to see how the numbers all add up very, very nicely. So let's go to this one. So I'm going to connect to sysdba. This is in my container. I haven't connected to a pluggable, so I'm at the very highest level. Let's have a look and see how many events I have for the Peel SQL timer. If you ever do dbms lock.sleep or dbms session.sleep for a certain amount of time, that's a wait event because you're telling the system, please wait for this many seconds. So far, this database has done none at the container level. Now let's jump into one of my pluggables. So this is PDB21A sitting under the same container. It also has no occurrences of Peel SQL timer. Let's introduce some now. So I'm just going to sleep for 3 seconds, right? And it's done. That is a wait event of 3 seconds of the Peel SQL lock timer. So now if I go look at VDOL event histogram for this particular one, you can see we've had none for a millisecond, we've had none for 2 milliseconds, but we had one await between 2 and 4 seconds, or 2,000 and 4,000 milliseconds. And that was the sleep for 3 seconds we just did. So at the PDB level, this single PDB here slept for 3 seconds, and we picked it up in the PDB level statistics. If I go back to the container level, what do I now see? I see a consolidated view across all the wait events. So in this case now, across all the PDBs, I had one occurrence of a wait of Peel SQL lock time between 2 and 4 seconds, the 3 seconds. What happens if I go to a different PDB in the same container? I very rarely use this one, that's why I have to open it up. So this is a second PDB, PDB21B. If I connect to that, it has no occurrences. Even though the container has one occurrence of a long sleep, PDB21A has a occurrence of a long sleep, this one does not, so it's not registered in its own local VDOL event. If I sleep in this one for 3 seconds, it now gets its own VDOL event histogram. Yes, you've got one occurrence in this PDB of a sleep between 2 and 4 seconds. If I go back to the container, unsurprisingly, across itself and all the containers, I've got 2 events now, 2 occurrences of that sleep, one in PDB21A and one in PDB21B. If I do a sleep in myself, I'm now in the container and do a sleep in here. It reflects the consolidation of all of them. I've now got one in my container, one sleep in my container, one in PDB21A and one in PDB21B, giving a total of 3. If I connect back as PDB21A and have a look, the fact that I did a sleep in PDB21B or a sleep in the container has no implication on the stats in my local pluggable. So it's, as you'd expect, but also very cool, because you need to remember that in reality, there is actually only one VDOL event histogram structure in the database. It sits in the container and it's measured across all the pluggables. But the fact that we have effectively structures in there which represent each of the pluggables plus the root container, you get this nice effect where the container contains a consolidation of all the statistics and each pluggable acts as if it is a totally standalone database with no knowledge of the other pluggables and no knowledge of the container as well. So you can happily run your AW reports in each pluggable, knowing that they'll be an accurate review of the pluggable itself. If you run the AW reports at the container level, you can get a consolidated view of the events across the entire set of pluggables. That may be appropriate for your scenario, it may not be, but at least you have the choice. Evolving to array processing. Here's the question that came in. I've been reading about bulk bind and array fetch or batch fetching. I'll read it in situ. But the demos are all about building programs, I assume, from scratch. We have complex existing code that is row by row, but I can't get my head around how to rewrite it all to use bulk batch. So just to fix up the nomenclature here, we're talking about bulk binding to get DML performance benefits and bulk collect to get array processing fetching benefits to get that benefit of pinning and less latching. Now, I will say, even though the question said, how do we rewrite it all? I'm not a fan of rewrite generally of code. And the reason is the risk profile is just too high. Anyone remember Netscape? Netscape, the browser, decided to rewrite their product. And where are they now? They just took too long. And this is on a smaller scale, a similar problem. If you can commit to rewriting your product, generally by the time it's rewritten, you've got not just the existing bugs you have to fix, you've got a whole plethora of new bugs that you have to fix and new testing. It's hard to justify that kind of investment. I'm a big fan of if you have a piece of code that you're unhappy with, what you do is you chip away at it, making improvements with minimal risk and still try to get as many benefits as possible. So I thought I would demonstrate that tonight just to prove that bulk binding, etc., isn't sort of sit in the domain solely of writing programs from scratch. So this is my fictitious scenario. We've got a customer products and sales kind of environment here, and for each, this is the requirement that's come in. For each product, and then for each customer, process the sales that are less than a quantity of 4. Call the discount web service to validate the details. And if the valid thing comes back as true, then log that sales row in the sales load table for later checks. So this is my fictitious, complicated application. So let's build it. Let's build it effectively as bad, and then we'll see if we can improve it by chipping away at it. So as I said, we're going to have some products, some customers, and sales. So I've got some products. I've got 100 different products. I've got 1,000 different customers. And my sales table is just grabbing random product IDs, random customer IDs, and then slamming them into the sales table, which consists of products, customers, a timestamp, an amount, and a price. You can see the amount goes from 0 to 9 because it's just simple modulo. So our requirement was go get these particular rows that had an amount less than 4. And so we're going to build a row by row style application that does this job for us. I know people who are on the call already, or people watching this going, that sounds like I do it with a single SQL, and we'll get to that. But let's build an application first and then see how we chip it away at it without needing to rewrite it to get all the benefits that we still would like to get. So I'll put an index on the sales table, and I'm going to need a sales load table. This is where my bad rows are going to get logged into. And because I've got a table, I'm probably going to have a little API that sits on the billet to actually log it. So if I need to log a row in this sales low table, I'll call this API, log a low sale, pass in the entire row as a row type variable, log it and commit it, and there's my little API. Now, the original spec was for each customer, for each product, loop through the sales. And this is that common mistake we make. We read a module spec and we build it as per spec. So the spec said, for each product that comes in and for each customer that comes in, loop through all the sales for that combination, find where the amount is less than 4. And if it's less than 4, call my very complicated web service, which might, in Java, goes out to the external environment, etc. Spoiler alert, this is just a Boolean that returns true for this particular demo. And if it returns true, then log a row calling that API we just built. So there's our little application, a little API called find the low sales. Now we need to do this for every single product and customer. So I'll set this one running. This is the row by row and the slowest of the code that we'll hopefully see tonight. But just while it's running, we'll walk through it. We have a cursor, which is the list of all the products. We have a cursor, which is a list of all the customers. So what I'll do is I'll open that one first, and I'm doing, as our poster said, we're doing single row processing. So We're fetching a product list and exiting when not found. Now that we've got our first product, we go get the customers, go get each customer for those. And now that we have a customer product pairing, I call it into that previous routine. For a given product and customer, find all the low sales, and for everyone I find, call the next API to log it in the sales table. And then I loop around and close my cursors. It took about 33 seconds. And so this is my hopefully reasonable example of an application that's been built based on various APIs. And because we're reusing APIs, we've ended up with a row by row, or as my friend Tom Kite used to say, slow by slow program. It's 33 seconds. How do we make it better? So the first thing I'll do, in terms of when you just want to chip away at things without making too much risk, the first thing I'm going to do is, how often do we commit? This is one of the most common performance tuning fixes I'll help people out with. We have this mindset of, because I need to restart something, and I'll talk about that in a second, I'm going to commit every single row. So the first thing I'm generally going to do is I'm simply going to look for where commits are and see if I can remove them. So I've just commented that out. And then I simply rerun that same routine. It took, 35 seconds the first time? Simply by taking out the commits and deferring it to the very end, we'll see if we get any improvements. And we've gone from 33 seconds, or 34 seconds was it, down to 13 seconds. And even though these are very short demos, that's not to be understated. That's literally getting 2.5 to 3 times performance benefit. Generally, if you go replace your server with brand new hardware, you might get 10% performance benefit. This is getting 300% benefit. So looking for removing of commits where possible is a really good idea. And I put in the myth of restart. Often when I suggest this to people, they go, oh no, we can't. We commit every single row because that means if something fails halfway through, we've got some of the work done. I'm absolutely amazed at the amount of times that people think by committing every single row, they've actually made their job easier when it comes to resolving errors after a failure. Generally, you've made things much, much worse. Because, for example, with this application here, by committing every single row, I could never run this again. It's not restartable because it simply loops through all the customers and products. The moment you start having intermittent commits in your code, you've actually increased the complexity dramatically in terms of being able to restart it, because now you need to be able to log where you're up to, because every time you run the code, it needs to say, have I completed 30% of the task? If so, I need to start at step 31 onwards. This code doesn't have that facility. And so I call this the myth of restartability. The more commits you have in your application, the less restartable it is. One commit at the end is generally better. But let's assume they have some facility better than this, where no matter how many they've committed, the next time they run it, it will pick up from where it left off. Can you still get some benefits? Yes. One of the common things I'll do is, if you want to make sure you commit only at certain intervals, but you don't really know how long does it take to process each product, each customer. If I put a commit at the end of each loop, is that going to be every second, every minute, every millisecond? Well, we can control it ourselves. I've created a little package called commit every, and it says procedure 5 seconds. No prizes for guessing how frequently I plan on committing here. And to do that, all I have to do is store a little package variable. I've got last commit, date, it's sysdate, because dates contain times as well. And all I do is, every time, if more than 5 seconds has elapsed, then I'll actually do a real commit and record this last commit time. So what this means is, if every time I call this package, I'll do a pseudo commit. I'll say, yep, I've done a commit, but I actually only do a real commit every 5 seconds. So once again, in terms of just chipping away at code with minimal risk, rather than comment out the commit, I simply replace the commit call with commit every 5 seconds. And we can set our code running again. And what this will do is, the code looks identical. I still need this trailing commit at the end here, just in case I finished, let's say, 3 seconds through. But now, assuming I've got all the restartability logic in there, which this one doesn't, then I'm going to commit every 5 seconds. No more frequent. I could have put commits at the end of each of these loops, but I then don't really know how often I'm committing. But in this case, I'm committing at most every 5 seconds, and I'm still down around that 13-second mark. 15 seconds, a little bit more time, but still I'm a lot faster than the original code. So that takes care of commits. The second thing is, the easiest way to get array processing on read is simply to use implicit cursors. I've lost track of the number of coding standard documents that say all cursors must be defined as explicit cursors, and then you must do open, fetch, etc., etc. I have no problems with having explicit cursors. I generally don't use them, but if you want to have them in there for documentation purposes, fine. But whenever you're looping through a cursor, just do for variable in cursor. That's all you have to do. The database will automatically take care of converting that into array processing. You don't need bulk collect, you don't need to declare nested tables or associative arrays and stuff like that. You just change your cursor processing to for variable in cursor, and we automatically do array fetch size of 100. So that's all I've done. I've simply taken my low-level API, which for a given product and customer just does now array processing on the sales rows, and I do the same thing with my actual anonymous block. Instead of opening a cursor, I do a for loop. Instead of opening a cursor, I do a for loop. That's all I've done. Let's see if we get any benefits. So I got some. I went down from 15 seconds because I'm still in commit every 5 seconds. Now I'm down to 10 seconds. Still, I'm getting 3.5 times now performance benefit from my original code spec. And I've done minimal changes to the code, and they're very, very low risk changes. Very easy to diagnose. Now, when it comes to doing bulk binding, once again, rather than rewriting all my code, I like taking advantage of the fact that we could intercept DML and do bulk binding as a separate activity, once again, minimizing that risk. So how can I take a piece of code that always does insert commands and convert it to bulk binding without rewriting it? So I'm going to build a little package here called pending rows. And because I'm doing bulk bind, I will need to define effectively an array type, but I've got this list of pending rows that need to be inserted. And all that's going to happen here is when someone calls insert into sales low, I'm going to pass in all the information that will be used to insert a row. But now let's look at the body and see what we really do. When someone says insert into sales low, I'm going to simply take this row that's come in. Sorry, the rows come in as individual parameters. I'm going to turn it into a single row type variable. And then all I'm going to do is I'm going to add it to my pending array. I'm going to simply build up a list of outstanding row changes that need to be inserted. When that size gets more than 1,000, I'm going to call the flush routine. The flush routine in the same package simply does a for all, does a bulk bind insert, so it's inserting 1,000 rows at a time as opposed to individual inserts, and then we delete the table again. So now, once again, all I need to do is go to my lowest level API, which used to be insert into sales low values, and change it to pending rows into sales low. I should have put values in there. You'll almost be identical text. Once again, very, very low risk, because if this was a much more complicated routine, all I'm doing is intercepting where the DML occurs. Put it into my anonymous block. A couple of things I need to add. Once again, low risk at the end of it, in case I've got any pending rows left over, flush them out, and then a final commit as well. And I'm down to 4 seconds. So from 35 seconds down to 3.9 seconds, putting my Oracle marketing hat on, you're verging on a 10x performance increase there, but you've chipped away at the code. Now, don't get me wrong. All of this, based on this particular example, is looping through a source, doing an insert, and calling a web service, and that web service returns a Boolean. So if I was fully refactoring this code, I would take my very complicated web service, which returns a Boolean, and put a wrapper function around it so it can return a Boolean to an integer, because as it currently stands, you can't refer to a Boolean in SQL. That'll be fixed soon. Create a function that wraps around that, and then I could do this. This is really the same functionality. Go get all the products and customers, all the values where the sales is less than 4, and the call to the web service returns 1, do an insert with it, and there's the rows, and it took 0.2 of a second, which is obviously about 300 times faster than the 35-second example, and a lot faster than the 4-second example. However, the reason I didn't want to show this up front is, in reality, if you go to your team lead, your project manager, whatever, and say, I've got 1,000 lines of code, I think I can replace it with 3 or 4 different insert statements and update statements, then that's going to create anxiety, because there's the testing process involved, there's throwing away a lot of existing code, a lot of knowledge over the years that accumulates in code that often often, we often think of as garbage, but sometimes it's intrinsically valuable. Ultimately, what I'm saying is I like the idea of leaving existing code in there and chipping away at it because it minimizes the risk and gets you 90% of the way to the performance benefits of perhaps a native SQL solution. And probably the most word of warning I come here is that it's so easy that when existing APIs exist out there, you say, there's an API to log a row. Fine, I'll use that for my batch process. There's an API that loops through a single customer. I'll use that to loop through all customers. And that's a very modular way of programming, but doesn't really suit SQL. So if I was rewriting it as SQL, that's fine. But if you want to take advantage of those APIs still, so you can say you're doing code reuse, look at opportunities of making or of augmenting the code such that you can effectively insert array processing both in the query phase and the insertion phase without changing the fundamental logic of the program. Now, obviously I'm a SQL bigot. I would say if you can go SQL, then do it, but there are risks involved. And I said, but you don't have to sweat about it. These are these kind of things where you go from 35 seconds down to 4 seconds and some smart ass comes along and says, you should have done it in SQL. Well, that's probably true, but if 4 seconds meets your response time, then be happy with it. You don't have to come up with a purest solution all the time. Constraints and locking. Here's the question that came in. We're doing warehouse style loads and regularly drop and recreate. We're doing warehouse style loads and we regularly drop recreate constraints, but it causes all sorts of locking issues. And the operations are generally very slow. Are there workarounds? And the answer is yes. The key thing here is understanding the importance of constraint state transitions and their impact on locking and performance. And probably best explaining all that gobbledygook with a nice simple demo. So I'm going to have 2 tables here. One's called parent or PAR, one's called child. Parent is a copy of DB objects, about 80,000 rows. I'll add a primary key. Child, I pre-created because it's got 24 million rows and 500,000 blocks. It took a long time to create, so it's already there. It has a column called P, which I want to add a foreign key back to the parent table. Now, because we're doing some locking stuff, I need 2 sessions here. So let's go to session 2. So here are some of the challenges when it comes to adding constraints. I go add this constraint on. And while I'm doing that, someone else wanting to do any work with this child table is stuck. You can see the first session is busily going through all those millions of rows, trying to work out whether each one's valid. While I'm adding the constraint, I've literally blocked access to the entire table. That's not ideal. It takes about 20 seconds, I think. So that's a problem in its own right. Once that constraint finally got added, then the DML in another session was allowed. But already we've got a locking problem here. Because if adding a constraint takes 10 minutes, I've effectively blocked access to the table for 10 minutes. Even worse is, while we have effectively open transactions on this table, things like more DML, like I want to do tomorrow's load, or the next load, I want to drop the constraint to do another load, is blocked as well. Okay? So how do we work around this problem first? Let's work on how to drop a constraint first in a nice, easy way. So all we have to do is, and this is a piece of syntax that not people are many aware of, is you can now do drop constraint online. Now, drop constraint online doesn't stop other people from doing work, right? They can still do work. What will happen is it'll wait until the table is not in an active transaction state. So if I roll back these or commit them, doesn't matter, then I'm allowed to drop it. But the cool thing there is now it's the drop constraint command that waits, and it hasn't blocked any other DML from occurring on the table. It's just going to wait until all DML is finished, and then you'll be able to drop the constraint. So that's cool thing number 1. This is the secret to getting constraints on in a very efficient manner. Apologies for my dog panting on the microphone. He's just off shot there. Rather than doing add a constraint, which by default will create the constraint and then validate all the data, do it in multiple phases. So in this case, I'm going to add the constraint, enable no validate, and that's instantaneous. So it says the constraint is now on for any new or modified data. The existing data hasn't been checked, but all new data is now going to be obeyed, and make sure it's checked that it exists in the parent table if it's coming into the child. Now let's go into session 2 and prepare a delete. And this is why it's cool. Now that the constraint is on, I can now go ahead and do the second part, which is let's make sure the old data is also valid. So I can do validate it. The cool thing is, unlike before, the child table is not locked. I can still do DML while the validation process is going on, because all DML that occurs now or in future is captured by the enable no validate. It's only the old data that is being checked with this kind of stuff. Now, even though I've got an active transaction here on the right-hand side, notice that the enable validate can complete successfully. It didn't get caught up behind an active transaction. I'll commit these and they're gone. But effectively, I can do this two-step process. This is instantaneous, and this can run and doesn't block DML on the child table. So that resolves the locking issue. Effectively now, I can have activity going on the child while I validate the constraint. So locking issues sorted. Let me roll back session 2. I think I've committed, but same thing. Now, I dropped the constraint again, so I'm going to go ahead and I want to add the constraint. So in this case, I'm going to get an active transaction here. Let's do enable no validate. So what happens now is, what if I have an active transaction going when I try to first create this constraint with enable no validate? Yes, this one will wait, but once again, my child table is not locked, right? The no validate is waiting for information here to be finished, and then it works. So once again, I haven't locked the child table. It's this person here that simply waits for DML to finish and then go ahead and does his work. Let's roll back session 2. I think I just committed. Yep, good enough. So locking problems, hopefully, are a thing of the past as long as you do this constraint transition from enable no validate to enable validate. The next thing is, what if I want to do that validation process much, much faster? So what I'll do is I'll make these tables parallel, because hopefully I can add a constraint in parallel to use all the power of my server. So I've made the child table parallel, made the parent table parallel, I've dropped the constraint. Let's get this one ready in session 2. This is a thing that's going to show me what sessions are currently active besides my own. So currently there's nothing active. Let's do this, the normal old style where I simply just try to add a constraint. If I run it, there's one active session. Even though these two tables are parallelized, if you just do alter table add constraint, like the old style, which does add the constraint and validates in one phase, you don't get any parallelization at all. Parallelism. You don't get any parallelism. And I'm back to 20 seconds again. This is another benefit of drop the constraint, of doing enable no validate first, and then doing the validate as a second phase. Look at the difference. Enable validate. I use the parallel engine now because the two tables are defined as parallel. And enable validate on a constraint that already exists in no validate mode can use parallelism. And therefore, rather than 21 seconds, it was 3 times faster. So to summarize that, almost all the time, whenever you're doing any constraint work, look at doing it in 2 phases, even if you're in small scale data here. Enable no validate, then enable validate. It involves locking issues and you open up the opportunities of parallelism for performance. If you're dropping a constraint, be aware of the online keyword. I think I said in an office hours session a while ago, whenever you're trying anything online, just add online to the end of it and see what happens. Drop constraints is one of those examples. That way you can drop constraints without having to wait for DML to finish. That way you can drop constraints without getting a resource busy error. It'll just wait for DML to finish. And what's more, it doesn't block any ongoing DML as well. Rebuilding text indexes. When we rebuild text indexes, it looks like we lose all the custom attributes we set. How do we preserve them? And this is one of those weird questions. I was bamboozled when I saw this, but there's nothing to worry about. The question is, where do the preferences go? And let's do a quick demo to show that. Create a table called T. It's a copy of DBA objects. I'm going to create a text index, and anyone that's used a text index knows you normally set various preferences that define how the text index will work. I'm going to go with the simplest one I can think of, and that is I'm going to create a simple storage preference, which says the I table and I index are going to go into a separate table space. If you've used preferences, there's all sorts of things in terms of dictionaries and lexes and whether it's got XML and JSON, all sorts of preferences that let you customize an index. This is a very, very simple customization. And this is what a text index looks like when I create it. I create an index, it's a context type index, and this is the key part. I add these parameters. I'm going to use the simple storage preference I defined, and I'm going to sync on commit. So this is important information for how the index will work. Where's it going to be stored? Where's some of it going to be stored? And how often will I sync the index? Now, if I go look at the parameters column in DBA indexes for my brand new index, as you'd imagine, there's a set. Yep, I'm using the simple storage preference and I'm syncing on commit. If I get the DDL using DBMS metadata, out comes the DDL exactly as pretty much I typed it. There's my index, there's the parameters, etc. Let's say now I set that index to unusable and I do some big scale load of the data and then I rebuild the index. Common technique, unusable, load lots of data, rebuild the index. So in this case, I just rebuild it. It's done. Here's where things get interesting. Look at my parameters. They're gone. How about DDL? It's gone as well. You should not use dbms metadata.getDDL for a text index because what comes out is different to your original source code. If this isn't a validation of you should have source code control, I don't know what is. So what's going on here? The way preferences, and in fact all the customizations work with a text index, is you define them in advance, but when you create an index, it grabs a snapshot of them. If I went back to my simple storage preference and said, I want to move it to a different table space, I want to add other tables to new table spaces, that has no bearing on this index. When I created this index, it effectively took a snapshot of all the bits and pieces, the various preferences I've set, and embedded them into the index. And they are now part of the index definition. There is no longer a link to effectively the preference as such. It was used effectively as a template to copy that information into the index definition. The preference now stands alone, and that's why we lose it here. The only way you can actually, if you want to get the full set of definitions back, you would actually do something like this. So first of all, just to prove that I didn't lose the preference, if I look at all the various underlying tables that exist for my index, it's still using large TS for the I tables and the I indexes. So it's still using the preferences I set, they're just not appearing in the DDL anymore. If I want to get the DDL, rather than use dbms metadDDL, you're better off using ctx report create index script and passing in your script. It returns a flob. And what it does is it returns the snapshotted elements that needed to be used to create that index. So you get all of it, a lot coming here. So if we scroll back quickly, was it 10 long? It says, I'm going to create an index called direct data store, null filter, null section group. These are all the things that were defaults it used, but they were snapshots. And so you would actually create your own should you want them. And then we have word list, a stop list, etc. All the bits and pieces that scroll down. It created a storage one. There's my previous stuff as before. And this is effectively what was run when we first built it. These are all the defaults that picked up various preferences, and then it did sync on commit. That's just a word of warning, right? Your preferences, all the information about that index is captured once when you create the index and is embedded inside the index. It's not going to be printed back out to you in DBA indexes in the parameters column, and it's not going to come out with dbms meta.getDDL. Use ctx report if you want to get it back, but ultimately this means just make sure you've got good source code control on your DDL scripts. Now it's 10 o'clock, but this is one last one. It only takes 2 minutes, so please bear with me. It literally takes maybe 2 minutes. Timing and set timing. In some part of SQL scripts, I see set timing, and in other parts, I see just timing. Is the latter just a shorthand for the other? And the answer is no, they are separate functions. And I thought I'd quickly finish off with these because a lot of people don't know about the timing function. If I've got a long query, I'm joining user source to itself. I go, oh, that seemed to take a bit long. What do I normally do if I want to see how long it took? I'll do set timing on. And I run it, and you can see it took about 2.5 seconds. It's a common thing we do. 2.5 seconds for that. Set timing on shows you the elapsed time for the last statement you run. The timing command is different. The timing lets you define start and end boundaries. So I want you to start timing, and I can run this query and this query and this query. When I do timing stop, I get the total elapsed time since I did timing start. So it's not times per each statement, it's simply a stopwatch. Start the stopwatch, finish the stopwatch, show me a thing. It's pretty cool. Even cooler is it's not just timing start and timing stop, you can have named timers. So I can say, I want to start a timer called overall, start a timer called query one. Query one finishes, so I want to stop the query one timer. Query one took 2.5 seconds. I continue on running this query and this query. I say timing stop the overall timer, which is this one, and it says yes, the overall time was 7.5 seconds, which makes sense, 3 times 2.5. So I can nest timers. So I can have a timer for the entire process, a timer for this much, a timer for this much, etc. I can have them nested. What I can't do is overlap them. So I can't start query 1 and 2, and then start query 2 and 3, and then stop query 1 and 2, and then stop query 2 and 3. I get the wrong results because they weren't nested. I actually had 2 timers that overlapped. Every time you hit a new timer start, we reset. So in this case, timer query 1 and 2, which was meant to take 5 seconds, didn't work. It said it only took effectively 2 seconds because the timer got reset here. So you can't nest them like that, but you can nest them in a hierarchical fashion. And finally, if I do timing start overall, I don't just have to do timing start and stop. If I want to see where I'm up to, I can say, show where the overall timer is up to. It's up to 2.5 seconds. Show where the overall timer is up to. It's 5 seconds. And then finally, we do timing stop. It took 7.5 seconds. Overall, this is a name I picked. It's not some keyword. You can choose whatever names you want. You can even have spaces in there if you put them in double quotes. So very, very cool. One thing to note, timing only exists in the SQL Plus command. It's not supported in SQL CL. Set timing is supported in both, but just the timing command is only supported in SQL Plus. And we are done. Only a touch late. Stop the share. As always, thank you so much for your time. Hopefully you understood my ranting and raving regarding user group content. I'll continue to do it. And hopefully you had still a lot of fun with the tech content and the demos, and hopefully you learned something today. That's always the aim of the office hours. Thanks for those that jump onto the chat and put in their comments, etc. Always good to have it interactive. I'm not sure if I'll have an office hours next month. I'm taking 2 weeks off sometime in March. As I said, the daily video has to go until then, but I'm not sure when the office hours is. It's the third Thursday of the month, but if not, I'll let you know. But certainly, if I won't be there, then it'll be office hours in April. But until whenever it is, thanks for your time. Thanks for sharing your knowledge and content with us. And hopefully you got something out of the content and knowledge we shared with you. We'll see you all again either next month or the month after for office hours. Bye for now, everyone.